2026 A-Level Chemistry Paper 1, questions 21 up to 30. If you are interested in the other questions from question 1 up to question 20 or question 31 up to question 50, then check out the links in the description down below. Now moving on to the first question, question 21 says, consider the reaction 1/2 A2 gas plus 1/2 B2 gas turning into AB gas. Given this, they say the ratio of the values of enthalpy of bond dissociation of A2 gas, B2 gas and AB gas is 2 to 1 to 2 and the enthalpy change for the reaction is negative 100 kJ per mole. Now given this, they ask us what is the value of the bond dissociation enthalpy of A2 gas in kilojoule per mole. Now to find this one, let's start off with this ratio right here. Now according to the ratio, if the bond dissociation enthalpy of B2 gas is equal to x kilojoule per mole, then for A2 gas according to the ratio, it will be 2x kilojoule per mole. And for AB gas also, it will be 2x kilojoule per mole. Now from this, the next thing we're going to do is to apply the fact that for any reaction, the sum of all of the bond dissociation enthalpies of the reactants minus the sum of all bond dissociation enthalpies of the products is equal to the enthalpy change. Now according to that, over here, for the reactants, we have 1/2 A2 and 1/2 B2, and therefore, for the enthalpy changes, we'll have 2x times 1/2 or 2x/2 for A2 and B2 times half, which is x divided by 2 for B2. Now that is on the reactant side. From that, we have to subtract all of the bond dissociation enthalpies on the product side. And on the product side, we can see all we have is AB gas, which is 2x. So therefore, we have subtract 2x. And that's equal to total enthalpy change of negative 100 kilojoules per mole. Now according to this, we can see, if we simplify, we get 2x plus x, or 3x/2. So we have 3x/2 minus 2x equals minus 100. And simplify, we can see, we can get 3x minus 4x/2 with the common denominator equals negative 100. And therefore we get from this negative x, and if we take 2 to the other side, we have negative x equals negative 100 times 2 or negative 200. And therefore x is equal to 200. Now from this, what we wanted was the value of the bond dissociation enthalpy of A2 gas, which is equal to 2x or 2 times x, which is 200 or 400. And therefore the answer for this question, the bond dissociation enthalpy of A2 gas is 400 kilojoule per mole. Now moving on to question number 22, the question says, an electrochemical cell was constructed using the platinum to iron 2 plus and iron 3 plus half cell and the platinum to manganese 2 plus, H plus and permanganate half cell at 25 degrees Celsius. Given that the question asks us which of the following is correct about this cell at 25 degrees Celsius, and it gives us the standard reduction potential of iron 3 plus to iron 2 plus, which is plus 0.77 volts, and the standard reduction potential of permanganate into manganese 2 plus, which is plus 1.51 volts. Now given this, if we look at the answers, we can see immediately answer number 1 and answer number 5 are both incorrect, as both of them have a negative value as the EMF of the cell. Now as we know, when you consider EMF, you always look at the spontaneous reaction, and therefore EMF of cell will always be positive. So due to that, the EMF of this electrochemical cell will always be positive value, and therefore answer number 1 and 5 are both incorrect. Now after that, if we then consider the reduction potential here, we can see, since the reduction potential of this one is higher, the reaction here of permanganate to manganese 2 plus will be the reduction reaction, and therefore the other reaction here will be forced to go in reverse and become the oxidation reaction. So this will be oxidation and this one will be reduction. Now according to that, since oxidation occurs at the anode and reduction occurs at the cathode, we can see this will be the anodic reaction and this will be the cathodic reaction. Now according to that, answer number 3 here is incorrect, as here the permanganate reaction is the anodic reaction, which is incorrect. It should be the cathodic reaction, and the iron 2 plus to iron 3 plus reaction is the cathodic reaction, and it should be the anodic reaction. Now with that, we only have 2 answers left, which are answer number 2 and answer number 4. Now the only difference between these two is in the cell notation here and here. Now looking at them, I can see the wrong answer is answer number 4 and the correct answer is answer number 2. The reason is, as a standard, In cell notation, we always write the anode on the left hand side and the cathode on the right hand side. But here we can see we have written the cathode on the left hand side and the anode on the right hand side. Now according to that, this cell notation is actually incorrect, as we should have the cathode on the right hand side here and this thing, the anode, on the left hand side here. So therefore, the correct answer of question number 22 is answer number 2. Now moving on to question number 23, the question says, consider the following compounds. It gives us 3 compounds A, B and C and then asks us what is the increasing order of ease of Fidelcraft acylation of these compounds. Now for this one we know that Fidelcraft acylation, or really any electrophilic substitution into the benzene ring, will become easier the higher the electron density in the benzene ring is. Now according to that, if we consider these compounds, we can see in A, we have a benzene ring attached to a pretty neutral carbon. Since this carbon is pretty neutral, the benzene ring's electron density here will be about equal to the standard benzene ring electron density of normal benzene. Now moving on from that, we consider B. In B, this carbon is connected to an oxygen which is highly electronegative. So therefore the oxygen here will have a delta minus charge, resulting in the carbon here having a delta plus charge, and this delta plus charge will pull some of the electron density out of the benzene ring. Therefore, the benzene ring here will have lower electron density than the benzene ring default, which is there in A. So therefore, B's electron density will be less than A. Now moving on from that, if we consider C, in C we have an oxygen directly attached to the benzene ring. Now due to this, since oxygen is highly electronegative, a lot of electron density from the oxygen will be close to the benzene ring, and therefore the benzene ring will gain some of that electron density, and therefore the electron density of benzene here will be higher than the default, which is there in A. So C will be higher than the electron density in A. Now combining these two, we can see we get the inequality B less than A less than C. And from this we can see, since electron density is proportional to the ease of Fidelcraft acylation, we can say the same exact order must be there for the ease of Fidelcraft acylation. And therefore the answer here is answer number 3. B less than A less than C. Next, if we consider question number 24, the question says the steps in the mechanism of a reaction that occurs in the presence of a catalyst are shown below, and we are given 3 steps, and interestingly we have an element here that we rarely ever see. We have the rare earth element cerium. So anyway, the question then asks us which of the following correctly identifies the overall reaction, the catalyst and the intermediate/intermediates of this reaction. Now for the overall reaction, all you have to do is to take these 3 reactions and simply cancel out any terms that we can see on the left hand side and the right hand side. Now from that we can see we have silver plus over here and silver plus over here, so they can cancel. And we also have silver 2 plus over here and silver 2 plus over here, so they can cancel. And we also have titanium 2 plus here and titanium 2 plus here, so they can cancel. Now after cancelling all those, we can see we're left with titanium plus and 2 cerium 4 plus on the reaction side, and on the product side titanium 3 plus and 2 cerium 3 pluses. So therefore answers 3, 4 and 5 are all wrong, and the correct answer is 1 of 1 and 2, because we have 2 cerium 4 pluses, 1 titanium plus, and on the product side we have 2 cerium 3 pluses and 1 titanium 3 plus. Now after that, if we then consider the catalyst and the intermediates, we can see a catalyst is a compound that is there at the start of the reaction, is consumed or changed somehow, and is replenished at the end of the reaction. Now according to that, we can see silver plus is there as a reactant at the start of the reaction, and at the very end of the reaction it is reproduced once again. So therefore silver plus is the catalyst, and the answer here is answer number 1. Now we can also see the intermediates here are silver 2 plus and titanium 2 plus. Now the reason these are intermediates is because somewhere in a step they are created and then later in the reaction they are destroyed such that they don't exist in the final products. So therefore the correct answer is answer number 1. This is the overall reaction. The catalyst is silver plus and the intermediates are silver 2 plus and titanium 2 plus. So with that, we're done with question number 24. Next, if you consider question number 25, the question says which of the following statements is incorrect. Now look at the first statement. It says when an inert gas is added to a gaseous equilibrium system in a closed rigid container at a given temperature, the total pressure of the system increases while the equilibrium constant remains unchanged. Now this statement is correct, as when you insert inert gas into a system, since the gas has its own partial pressure, it will increase the total pressure. However, since the gas doesn't change the temperature, it's at the same given temperature, the equilibrium constant will remain unchanged. Now moving on to statement number 2, the statement says, when an inert gas is added to a gaseous equilibrium system in a closed, flexible container, i.e. the volume can change, at a given temperature, while keeping the total pressure constant, the equilibrium constant remains unchanged. Now this statement is also correct, as while the volume does change, since the temperature remains constant, the equilibrium constant will remain constant. Now moving on to statement 3, it says, when the pressure of equilibrium system of 2 mercury oxide solid in equilibrium with 2 mercury liquid plus O2 gas in a closed rigid container at a given temperature is increased, the equilibrium point shifts to the right hand side. Now this statement is actually an incorrect statement and is therefore the correct answer. The reason it's incorrect is because if you consider Le Chatelier's principle, when we increase the pressure of O2, the concentration of O2 will increase, and since if we have any kind of reaction, Le Chatelier's principle says the equilibrium will try to shift in the reverse direction such that the reaction that we create on the system is reversed. When we increase the pressure, i.e. the concentration, it will try to go in the reverse direction to reduce the O2 concentration, and therefore the equilibrium will shift to the left hand side. So the answer here is not to the right hand side but rather to the left hand side. So the answer is answer number 3. Now since answer number 3 is the incorrect one, it also means automatically answer number 4 and answer number 5 are both true statements. And with that, we're done with question number 25. Now moving on to question number 26, this question actually has a mistake in it, and I'll be showing you the mistake as we go along. So the question says, the solubility of magnesium hydroxide in water at 25 and 100 Celsius are 1.0 times 10 to the minus 4 and 4.0 times 10 to the minus 3 moles per deciliter cube respectively. Now given that the question asks us, how do the concentration of OH minus aqueous and the pH value of and here it's supposed to say of a saturated magnesium hydroxide solution at 100 Celsius differ from those of saturated solution at 25 degrees Celsius. Now as it turns out, without the saturated word, the question actually doesn't make any sense, and therefore for the purpose of this video, I'll be keeping the saturated word and solving the question based on that. Now based on that, at 25 degrees Celsius, the magnesium hydroxide concentration of a saturated solution will be equal to 1.0 times 10 to the minus 4, and similarly at 100 Celsius, magnesium hydroxide concentration will be equal to 4.0 times 10 to the minus 3. Now according to this, since when magnesium hydroxide dissolves in water, it will dissociate as magnesium 2 plus and 2 OH minuses, the concentration of OH minus is equal to double the concentration of magnesium hydroxide, and therefore OH minus at 25 is equal to 2.0 times 10 to the minus 4 and OH minus 100 Celsius is equal to 8.0 times 10 to the minus 3. Now according to this we can see, comparing OH minus concentrations, the OH minus concentration at 100 Celsius is higher than that at 25 degrees Celsius, and therefore answer number 3 and 4 are not the correct answer. Now considering the next part, to find the pH, we have to first find the H plus concentration. And to find the H plus concentration, we have to use the next part of information that they're given here at the end of the question. So at the end of the question they say, at 25 degrees Celsius Kw is equal to 1.0 times 10 to the minus 14, and at 100 Celsius Kw is equal to 5.5 times 10 to the minus 14. Now Kw is equal to the concentration of H plus in water times the concentration of OH minus in water at a given temperature. So according as we can see, the H plus concentration will be equal to Kw divided by the OH minus concentration. Now according to that, if you take a look at 25 and 100 Celsius, at 25 Celsius, we have OH minus concentration being equal to 2.0 times 10 to the minus 4, and therefore the H plus concentration will be equal to Kw of 1.0 times 10 to the minus 14 divided by 2.0 times 10 to the minus 4. Now from this we can see we have 1 over 2 or 0.5 or 5 times 10 to the minus 1 times 10 to the minus 14 divided by 10 to the minus 4. And these two simplify to give us 10 to the minus 10. So we have 5 times 10 to the minus 1 times 10 to the minus 10, which is 5 times 10 to the minus 11. Now similarly at 100 Celsius, H plus concentration will be equal to Kw, which in the case of 100 Celsius is equal to 5.5 times 10 to the minus 14. So 5.5 times 10 to the minus 14 divided by the OH minus concentration of 8.0 times 10 to the minus 3. Now dividing we can see 10 to the minus 14 divided by 10 to the minus 3 is equal to 10 to the minus 11. So we have times 10 to the minus 11 and 5.5 divided by 8.0 is some number less than 1. So therefore, we have a whole number here and 10 to the minus 12. Now if I actually take the value, 5.5 divided by 8.0 will be equal to 0.6875 So 0.665 times 10 to the minus 11 is equal to the H plus concentration at 100 Celsius. And we can see this number is a smaller number than this number right here. Now according to that, since the pH is equal to the negative base 10 logarithm of the H plus concentration, having a low H plus concentration means you have higher pH, and therefore at 100 Celsius the pH is higher than that at 25 degrees Celsius. So therefore, both the OH minus concentration and the pH are higher at 100 Celsius, and therefore the answer is answer number 2. Now here it should be noted, we only got this answer by assuming that we have saturated solutions over here. So with that, we're done with question number 26. Now moving on to question number 27, it says, how many isomeric compounds exist with the molecular formula C8H8O which have benzene ring in its structure and give a colored precipitate with 2,4-DNP. Now to solve this question, let's start off with the benzene ring. So benzene ring has 6 total carbons and 6 total hydrogens. However, we need 8 total carbons. So therefore, at least one of the hydrogens in the benzene ring has to be substituted with a carbon atom. So we need at least this. Now from here, since we have 7 carbons, we still need to add 1 more carbon. And we have a choice in where to add it. We could either A, add it onto the benzene ring, in which case we'll have 3 choices of either putting it in the ortho position like this, or in the meta position like this, or in the para position like this. So we have 3 total choices in the case where we put it somewhere on the benzene ring. Now instead, we can also put it on the second carbon over here, and therefore we'll get the skeleton of benzene ring, 1 carbon and another carbon on there. Now from here, in order to place the oxygen, we have several choices. If we first consider these skeletons, we can see we can either place the oxygen on this carbon or this carbon, and in the case of this one, on this carbon or this carbon, and in the case of this one, on this carbon or this carbon. However, due to symmetry, all of those are all the same, and therefore all you need to do is to pick the carbon and put the oxygen on. Now in this case, since this compound must give a colored precipitate with 2,4-DNP, we must have a carbon-oxygen double bond somewhere in the structure, and therefore for the first structure, the only structure we can make here is by putting a carbon-oxygen double bond like this and creating an aldehyde. And similarly for this one, the only structure we can make is by putting a carbon-oxygen double bond like this. And finally for this one, only structure we can make is by putting carbon-oxygen double bond like this, which will satisfy all of the conditions here. So therefore, we have 3 structures from all of these skeletons. Now if we consider the other skeleton, in order to have a carbon-oxygen double bond, we have 2 places to put the oxygen. We could either put it here or here, and therefore this skeleton actually gives 2 answers. It gives us the one where you have carbon-oxygen double bond on the first carbon, which gives us a ketone, and we also have the second one where we have carbon-oxygen double bond on this carbon, which gives us an aldehyde. So therefore, we have 5 total structures that will satisfy all the conditions given here, and therefore the answer to this question is answer number 4, 5 total structures. Now moving on to question number 28, the question says, the given graph was obtained from several experiments carried out for the dissociation of the metal carbonate MCO3 to MO and CO2 at a particular temperature in a closed rigid container. Given that they also say the concentration of CO2 were measured on change in the initial amount of MCO3. Now given that they ask us which of the following statements is incorrect about this system, and here they say K is the equilibrium constant and Q is the reaction quotient. Now if we look at the reaction that's happening here, we have MCO3 solid in equilibrium with MO solid and CO2 gas. Now here, since both of these reactants and products are solid and only this one's a gas phase, we can say the reaction constant K here is going to be equal to the gas phase compound of CO2 raised to its power, which is the coefficient of 1. So therefore, K is simply the concentration of CO2. Now according to that, until the CO2 concentration gets to K, we will not have an equilibrium, and after that, the CO2 concentration cannot be higher or lower than K. Now looking at the answers, we can see the first answer says the equilibrium MCO3 solid to MO solid plus CO2 gas is established only after the point A. Now look at the diagram, you can see for all of these values, as we increase MCO3 concentration, the CO2 concentration did not go above this certain point. Now according to that, we can see what's happening here is that the MCO3 amount is not sufficient to get the CO2 concentration all the way up to K. So therefore, it stops right here due to this amount being a limiting reagent. However, after this point, the graph doesn't continuously go up, and that's because after that point, we reach the equilibrium concentration of CO2, and therefore, the concentration stays as it is, and the MCO3 stops breaking down into CO2 at that point. So therefore, the graph does in fact say that after the point A only is the equilibrium established. So that means statement 1 rather, is correct. Now moving on to number 2, it says at the point B, Q is greater than K. Now at B, the concentration of CO2, which is Q in this case, is going to be equal to some value of CO2, let's say CO2 concentration dash, which is higher than the equilibrium concentration K. And therefore, it is in fact correct in saying that Q is greater than K. So statement 2 is also correct. Now similarly for statement 3, it says at the point C, Q is less than K. And at this point, Q, which is the concentration of CO2 at that point, which is going to be CO2, let's say dash, is some value that is less than the CO2 concentration of K. And therefore, we can say that Q is less than K at the point C. So that is also a correct statement. Now moving on to number 4, it says beyond the point A, the pressure of the system does not change. Now since we have constant concentration here of CO2 and also we have the same volume and same temperature, we can conclude based on the ideal gas law that the concentration of CO2 remaining constant will ensure that the pressure will also remain constant. So therefore, after the point A at equilibrium, the pressure will remain constant. So statement 4 is also correct, meaning 5 must be wrong, and therefore the answer is answer number 5. Now here 5 is wrong because it says at both points B and C, Q is equal to K, which is contradictory with 2 and 3. And therefore, if 2 and 3 are correct, which they should be, then 5 is the incorrect answer. So the answer for question number 28 is answer number 5. Now moving on to question number 29, it says the reaction of metallic sodium with water is an irreversible reaction. 1.8 grams of pure water was cautiously added to 460 grams of metallic sodium. Given this, they ask us what is the maximum amount of hydrogen gas produced in moles in this situation. Now to find this, let's first find the number of moles of water that are used in situation and also the number of moles of sodium that are used in situation. Now in terms of water, we have 1.8 grams divided by the molar mass of water, which is equal to 18 gram per mole. Now dividing, we can see we have 0.1 moles of water. Now doing the same thing for sodium, we have 460 grams divided by 23 gram per mole, which gives us a total of 20 moles. Now from this we can see, since sodium and water react as sodium plus water turning into sodium hydroxide plus hydrogen gas and if you balance it, you get 2 sodium hydroxide, 2 waters and 2 sodiums. We can see, since these react in the 1:1 ratio, the limiting reagent here is the water. So therefore, 100% of the water will react to form hydrogen gas. Now according to the mole ratio, we can see 2 waters will make 1 hydrogen, and therefore 0.1 moles of water will make 0.1 over 2 or 0.05 moles of hydrogen gas. So therefore, the maximum amount of hydrogen gas created is 0.05 moles, or answer number 5. And now finally, if we consider question number 30, the question says, when dilute HCl is added to a solid sample of a mixture containing calcium carbonate and zinc carbonate in a 1:1 mass ratio, a clear solution is obtained. The calcium 2 plus zinc 2 plus mole ratio in the final solution is approximately how much? Now to find this one, all you have to do is to equate the two masses of the mass of calcium carbonate and the mass of zinc carbonate to a certain value, let's say m, and then compare the number of moles of calcium carbonate to the number of moles of zinc carbonate. Now to do that, what we will do is to find the molar mass of calcium carbonate and the molar mass of zinc carbonate. Now findings, if you can see, for calcium carbonate, we have 1 calcium which is equal to 40 gram per mole, plus 1 carbon which is 12 gram per mole, plus 3 oxygens which are each 16 gram per mole. So 3 times 16. And for the zinc carbonate, we have zinc which is 65 plus 12 plus 3 times 16 for the oxygens. And therefore, if we solve this, we can see for the calcium carbonate, we have 40 plus 12 which is 52 plus 3 times 16 which is 48, and 52 plus 40 is equal to 100 gram per mole. Now similarly, if we simplify the other one, we can see we have 3 times 16 which is 48 plus 12 which is 60, and 60 plus 65 is equal to 125 gram per mole. Now according to that, we can see the moles of calcium carbonate is equal to m divided by the molar mass of 100 gram per mole, so divide by 100. And also the mole of zinc carbonate is equal to m divided by molar mass of 125. Now according to, if we simplify, you can see the ratio of m over 100 to m over 125 is equal to the ratio of 125m to 100m, which is equal to the ratio of 125 to 100, which is equal to the ratio of 5 to 4. Since if you divide both of these by 25, you get 5 on this side and 4 on this side. So therefore, the ratio of moles of calcium carbonate to zinc carbonate is equal to 5 to 4. So according to the correct answer here is answer number 2, 5 to 4. And with that, we're done with all of the questions from question number 21 up to question number 30. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching, and goodbye.